Section 1.5 is on proofs that are not valid. When proving a statement or a conjecture, it is important to make sure the proof is valid. Some examples of errors in proofs which make the proof invalid include: the proof begins with or contains, not containing, that should be contains, a false statement. The proof contains algebraic errors. The proof contains a mathematical error, such as division by zero, because you can't divide by zero. The proof contains reasoning which uses what you're trying to prove, or what we call circular reasoning. So here are some examples now of these types of errors. So the first one says, and we got to find the errors in each of these proofs. It says, all high school students like Facebook. Rebecca is a high school student, therefore Rebecca likes Facebook. And the error in that proof is that this statement here at the beginning is not necessarily true. There are lots of students who don't like Facebook. So this would be one that has a false statement or assumption. Not all students like Facebook. So the next example says, Shelby was trying to prove this number trick. Pick a number, so she let n be the number. That's okay, and she doubled her number, which would be, if n was her number, then 2n would be doubled. That seems to be okay. Then she added 20, so 2n plus 20 would be the next step. Then she divided by 2 and got n plus 20, and that would be an error in calculation because 2n plus 20 divided by 2 would actually be n plus 10. So that's a mistake in this proof here, and that would be a calculation error, or what did they call it up top there? Algebraic error. Okay, so this would be an algebraic error. The next example, Pedro claims that he can prove that 2 is equal to 5 and his work is shown below. So he says, suppose you start off with a equals b. So then he multiplied both sides by -3 and got -3a equals -3b. Okay, that's reasonable. Then he added 5a to both sides, so -3 plus 5a equals -3b plus 5a, which sounds reasonable. And then what he did is he combined these two, -3a and 5a, to give you 2a, equal to -3b plus 5a. The right hand side stayed the same, so that's okay. He simplified. Then he added, or subtracted, sorry, -2b from both sides, which seems okay. And then he's got the left side is 2a minus 2b, and the right side he combined the -3b and the -2b to give you -5b. So you end up with 5a minus 5b, so that's okay. And then what he did is he took this left side of the equation and factored 2 out as a GCF and got 2 outside of a minus b. And similarly on the right side he factored the 5 out and got 5 outside of a minus b, which is okay. But this is, in step 7, this is where the error is, because if you divide by a minus b would equal 0, since a equals b was given at the beginning. So if a equals b, then a minus b is 0, and therefore you can't divide by 0, so this is a mathematical error. Can't divide by 0. Doesn't make sense. And his whole proof is based on that, so therefore the proof is not a valid proof. Okay, the next example, that numbering is wrong. This must be example 5, is it? 3, I can't remember. Anyway, this is not right. Richard was given the following situation. Miss Lily is a teacher at K High School. Jessica is a student at K High School. Write a conjecture about the relationship between Miss Lily and Jessica. Richard represented his conclusion in the Venn diagram below and concluded that Jessica is a student of Miss Lily's. Well, in the way that he has his diagram drawn, that would be the conclusion, but we can assume that just because Miss Lily is a teacher at K High School and Jessica is a student at K High School is not necessarily true that Jessica is in Miss Lily's class. So the way he's drawn it, it's misleading, and we aren't certain that Jessica is not necessarily, there's no information there to indicate. So she's not necessarily a student in Miss Lily's class. So we don't have enough information there. So the diagram is drawn incorrectly. Diagram is not drawn accurately for the information. From the info given. Okay. So that would be the error for that one. Okay, the next proof has an error in it as well. This is Darren claims he can prove the sum of the interior angles in a triangle is 180. So here's his proof. I constructed a rectangle. Nothing wrong with that. Next I drew a diagonal. Nothing wrong with that. I knew all the angles in a rectangle are 90. So he labeled one or the other. So he knows that this one here now is a right angle. So that's fine because all the angles in a rectangle are 90. So then he said he labeled one of the other angles in the triangle that he's got formed as x. Therefore, he said that this one here has to be 180 minus 90 minus the x, because this is 90 and this one is x. And that he's using here the idea that the sum of the angles of a triangle is 180 degrees, which is basically what he was trying to prove in the first place. So therefore, his proof is basically using what he's trying to prove what he's trying to prove. His proof is using circular reasoning. He is using what he's trying to prove in his proof. He is using what he is trying to prove. In his proof. So he's trying to prove that, but in proving that, he's using that as if it was already a proven fact. So that's what we call circular reasoning. So it's not true. It's not a valid proof. So again, there's some examples there on page 42 that you can try in your notebook, in your textbook, to practice these things.